Hi, and welcome back. I'm Hank Preston, a developer evangelist with Cisco's DevNet organization, and I'm here today to talk to you with our Python Part 2, working with libraries and virtual environments. This is part of our Network Programmability Basics video course, and it's in the module on Programming Fundamentals. Now, this is our second of 3 Python lessons. We've already covered the basics of the Python language and writing scripts and working with the interpreter. If you haven't seen that lesson, be sure to go back and check it out. And then after this lesson, we'll dive deeper into Python libraries specifically helpful for network engineers as they're working with network programmability. If you want to follow along with me as I'm doing the examples, please do. I encourage it. You can find all of the code and details on how to run these exercises up on GitHub at github.com/cisco-devnet netprog_basics. Every lesson includes a README that details how to get your laptop set up to run these exercises, as well as details on any DevNet sandbox that you may need to run these exercises should you need infrastructure for a particular lab that we're going to go through. Let's dive right in. What we're going to cover in this lesson are what exactly is a Python library and how might we use them, and what will they offer to us as we go through. We'll look at how do we use the pip utility inside of Python to install those libraries and take advantage of them. We'll look at virtual environments and why we might want to use those to separate some of our different Python projects that we're going through. And then lastly, we'll look at a handful of foundational libraries that you should be aware of inside of Python to make your life easier as you go through. So what are libraries and why might we want to use them? What are they going to offer to us as a programmer using Python? And so Python libraries are, simply put, just any Python code outside of your script, outside of your information that you've created that you might want to use. A Python library will provide some capability or data that you need to take advantage of what you're after. And you'll see those at the top, typically at the tops of a script, using include statements such as from the library, import a particular name or object from the library. Or if you want access to an entire library, you would just import library and then you'd be able to access it. Now let's dive into this sample script here and look at how we might use it. All right, so inside here we can see that we're importing 2 elements. The first one we're doing is from common vars import shapes. And so the way that we look at this is there's a library, there's some Python code someplace called common vars. And inside of that library, there's a name called shapes. There's an object, a variable called shapes. And I need access to that data inside of my script. The second bit that we're going to import is called datetime. Datetime is an embedded core foundational library inside of Python that lets you work with dates and times. And we'll see more capabilities on it in just a bit. Now, once we've imported the shapes object that's available, now I can take advantage of it inside my code. And we can see that here inside of this for loop. So I'm looping over each individual shape in the shapes list that are available that I imported from common vars, and I'm just printing out the name of the shape. Now you'll notice nowhere above here, right? I didn't define what shape is. I don't see that. I simply have access to it because I've imported it, and now I can take advantage of it directly inside of my code. Now for the datetime piece, what we do with datetime is an entire library with capabilities that offer us all sorts of features that we can use for date and time inside of Python. And so what I want to do is I want to get the current date, the current date and time that are out there, and store that as a name called date now. To use that, I go into the date time that I've imported. Date time has another object inside it called datetime, so we use the datetime.datetime. And that object has a method called now that I'm going to reference and call. And that then provides me back the actual datetime that's there. Now I'm also using datetime for a couple of other features in here. In addition to the datetime now, I'm also doing time math, which is a huge capability of datetime. If you've ever tried to do math based on seconds and minutes and then factor in leap years and how many months and days there are in different months, you know how challenging that can be. Using the datetime library and this time delta capability of I can very easily do math, and I can create a new date where I take the current date and then I just add in 1,000 minutes. Right? Very simple to do date math using this library. If I couldn't import that in using the datetime library, it'd be much more complicated for me to do that aspect inside of my code. Now you may wonder, where do I get libraries? Where would I find access to them, all of these resources? Well, there are several places they can come from. The first one is you can write them yourselves. as we saw with the common vars where I imported shapes, you can write any bit of Python code and then import that in as a library using an import or a from statement. You can also take advantage of hundreds of included libraries that come with Python natively, just as part of the language. Some examples that we've already seen are datetime, OS, sys, JSON. All are included natively with Python, and you can simply just import them directly. Now, the Python package index, something we call PyPy, provides a library in an area up on the internet for open access to libraries that you can download for capabilities. So any Python developer can create a package, create a library that does some sort of action, package it up and publish it on PyPy. And then the pip utility inside of Python gives you the ability to install and download directly from PyPy and install into your environment the libraries that are available. Now, not every library that developers have created are available on PyPy. Due to copyright restrictions or access, there may be lots of reasons that a developer doesn't want to post their code directly up on PyPy for use like that. In that case, you can download and install them manually. And an example of that would be the ACI toolkit put out by Cisco, which is a set of scripts, libraries, and applications to interact with the ACI data center SDN platform that are there. Now, most of the places you're going to get, most of the libraries you will use inside of Python probably are available from PyPy using pip. So let's take a look at how we would use pip to install libraries. Now, pip is the Python package installer. That's what you're trying to use in this case. And since Python 2.7.6 or 3.4 and later, it's been included by default with Python. So you probably already have access to it just based on installing Python. It integrates and will search the PyPy index for packages as you do searching for them, and gives you the ability to install, upgrade, or uninstall and delete them. Now, if you're looking at Python projects on GitHub, or you're taking a look at maybe some script information that's there, a common element you may see is a text file called requirements.txt included inside of code repos. Now, what requirements.txt is its input that you can pass directly into pip to install all of the necessary libraries for this function and code to work. Now, the common commands for pip that you should know and be comfortable with are pip install to install any package. Now, if you've already installed a package and then that package gets upgraded with bug fixes or new features, you may want to upgrade it. So pip install -- upgrade, the package name, will search PyPy and download the latest version of that package and replace the one that you've currently got installed. If you find that you don't need a package, you can uninstall it with pip uninstall package. Once you have your script, you have all of the libraries installed necessary, you may be curious about what packages you actually have installed in a particular environment. Using pip freeze will output that command, output all of the libraries that you currently have listed, as we can see in the screenshot behind me here. Now, lastly, if you want to install those requirements, you've got your Python, you've downloaded a repository or a set of script from GitHub or some other source, and there is that requirements.txt file. With a simple pip install -r requirements.txt, it will then go ahead and install all of the requirements listed in the requirements file into your environment automatically for you. Now, I've mentioned the word environment a couple of times. Let's take a look at another technology that's offered with Python that's super helpful for developers or just network programmability people to understand and effectively use Python, and that's called virtual environments. Now, what a virtual environment is it is an isolated, fully functional Python environment on your workstation. This means that you can have multiple Python environments on your workstation all at once. And here we can see that we've got 3 different Python environments. Now, why you might want multiple ones is maybe you've got a set of script or a code or a program that requires one version of Python, in this case maybe 2.7. And then you have another script or another function that requires Python 3. Also, we've got different libraries we can include inside the virtual environments. So in our default Python environment on our workstation, we may have a very thin, very limited set of Python libraries included. But for our project called Virtual Environment 1, we install a robust set of ACI and network programmability and netconf yang libraries to work with. And then in Python 2, we're going to be doing our Ansible work. So we have, in that case, a different set of Python libraries included. Virtual environments are very handy inside of Python to do this isolation and get set up. And it's one of the things that I wish that I had started using earlier as I was working with Python myself. So I include it here so that you can get comfortable with it as early as possible and work it into your general workflow of Python scripts. Now, how you would use a virtual environment would be like this. We have to install the virtual environment library. It's a capability, it's something written in Python. And we use pip to install it, just like any other library or capability with Python. So pip install virtual environment, as we can see there in red in the example. Now, once we have virtual environment created, we can create as many virtual environments as we want simply by calling virtual environment and then the name that we want our virtual environment to have. Now, a common practice, you'll see the virtual environment's named VENV for virtual environment, but you don't have to use that. That's just kind of a standard you'll see. Now, if you want to specify a Python version, maybe on your laptop, on your workstation, you've got Python 2 and Python 3 installed. Well, virtual environment by default will use whatever is considered the default Python environment on your laptop. Now, it's recommended to leave the default with whatever your operating system wants it to be. So for Macs, for example, that's Python 2.7. Now, if I wanted to create a virtual environment using Python 3, I would use virtual environment, the name of my virtual environment, say VNV2, and then -- Python equals Python 3. And so this will create a new virtual environment based on Python 3. Once I have that virtual environment created, we need to activate it so that it's in use inside of our terminal window. And we do that by using source, the name of our virtual environment, /bin/activate. That enables our virtual environment, and we can tell that it's enabled by our command prompt will then be prefaced inside of parentheses with the name of the virtual environment, as we can see at the bottom of the example here on the screen. Once you're done working inside of your virtual environment, just type deactivate and it will return you back to the default virtual environment for your operating system. Now, one thing to note, if you're working on a Windows platform, virtual environments in Python are definitely available, but the scripts to activate are slightly different. Rather than being source virtual environment bin activate, it would be virtual environment /scripts/activate to go through. So very similar, just a slight difference as far as that goes. Once you have your virtual environment set up, installing Python libraries within it are no different than we've already talked about. You activate your virtual environment and then just pip install whatever you need access to inside of that bit of code, or inside of that bit of piece. Now back to some foundational libraries. So Python includes several libraries by default out of the box that you might want to be aware of to be able to take advantage of. Now, I can't cover them all in this video course, but I want to highlight a few that are good to know that are there for different use cases you may have. Those are PrettyPrint, which gives us a nicer print utility. The Python interpreter utilities. How do you get access to your running status of your script? Have there been any errors? Is there any information about the Python version that I need access to? You want to interact with the operating system, work with files, work with directories. The OS library gives us that ability. And as already mentioned, datetime is hugely valuable for all of the utilities to get access to a date, convert timestamps, format dates that are out there. Now, why you might want to use PrettyPrint is because the default print view is handy, but it just prints out the string that's there. Now, in this example, what we can see is we're printing out the list of books, and it just gives us the list of books in a single line. Now, if I use pprint, what's nice here is each element in the list will get its own line on there, and it breaks it down. It just makes it easier to read. So PrettyPrint is a handy one to know if you're trying to print out a lot of detail and data. Now, the OS library, or the sys library, gives us the ability to access details and variables about the running state of Python. Now, a common area I use this for is if I need to get access to arguments that were passed into a script. So sysargv gives us a list of all of the arguments that are there. So in our screen here, we can see that I've opened up Python using I've opened up Python in an interpreter window with common vars as the Python script we're going to run, and passing in a couple of command line arguments. And then using sysargv, and then in brackets 1 and 2, I can access those individual command line arguments that are there. Now, the most common place you'll see sys used is with sys.exit, to exit with an error code. So if you do have your function going through and there's a problem and you want to make sure that you end and you provide some details about that error, you can sys.exit, and then inside the quotes, you can provide details. Now, any message you provide will indicate that this script ended with an error state, but you can always just call sys.exit with no message, and that'll show that the script exited cleanly in a correct fashion. Here we can look at the OS library, which gives us the ability to access and manipulate directories and files inside of the operating system. So one thing to note, if you want to just open a file to read or write it, as we saw in Python part 1, you can do that just with the open command directly. But if you want to find out what directory you're in, or get access to the full the full path of the directory you're at, or the path of a file, you can use the OS library to change working directory or get the working directory that are there. Now, the OS library is also hugely helpful to access environment variables inside of the system. So you can both read environment variables, as we can see with os.environ on the screen here, pulling out the user information, but you can also write them. So you can set new environment variables from Python using the OS library that's there. Now lastly, we want to talk about the date-time one, probably the most powerful built-in library that you'll use over and over again. Or at least maybe not the most powerful, but certainly the most handy. So datetime gives us the ability to create, format, and manipulate the times, as well as I mentioned, that time arithmetic. If you're trying to figure out what date it's going to be in 4 weeks or what time it's going to be in 2 years from now as it goes through, you can do that very easily using the datetime library. The other piece that datetime provides is native conversion from Unix timestamps and other formats where you may get information that isn't terribly valuable or isn't readily readable or understandable to the human eye, but it's still a time, and you want to convert that timestamp to something that you can read and then display it. And we can see in the example here where we're using string format out there to format a particular time in something that would be readable to our users. Let's take a look at some of these different elements in action and how we can take advantage of libraries inside of Python. All right, let's take a demo and take a look at how we can use PyPy in order to use to gain access to the full library of available packages and libraries in Python that are out there. And so here we're taking a look at the latest version of PyPy, and as you can see by the indication on the screen, this is the kind of the pre-production or beta version of the new version of PyPy, but it works, so let's take a look and use the latest and greatest that's out there. And so let's say I'm writing some Python scripts, some Python code, and it's supposed to be a fun little project, and I want to have something to work with some different jokes. But I don't have the time to kind of invent a bunch of jokes myself. So let's look and see if there are any libraries inside of PyPy for jokes. So simply by searching for jokes, I can see that in fact there are a lot of them. There are 144 projects that match jokes, giving me different types of pieces that are there. I can filter down the available ones based on operating systems, language versions that are there. But in this case, I'm just going to go ahead and say this PyJokes one looks pretty good. Jokes as a service, right? Who doesn't like jokes as a service? So each of the projects inside of PyPy will give us information, right? How to install it. So pip install PyJokes, just as we've seen, that's simple to go through. And then I can read through the documentation on PyJokes to understand how to use it. And so I can see here that there are a couple of capabilities once I've installed PyJokes. It comes in as a command line where I can just call it directly with PyJoke, or I can then import it into my projects and then use functions getJoke or getJokes that are there. Well, this seems perfect, not to mention the fact that it does offer me more Chuck Norris jokes, which are always a big win for me. So let's go ahead and say this is the library I want to use. So to get started with that, I'll jump back to my browser or my terminal window and we'll get started. Now I want to create a virtual environment for my jokes project. So we'll do that with virtual env, and we're going to call this our jokes virtual environment. Now for my project, I want to make sure that I'm writing this in the latest version of Python, so I'll say Python equals Python 3. This will create me a new virtual environment using my version of Python 3, in this case version 3.6.2, which at least when I'm recording this is the latest version of Python 3. And this will go ahead and install it. Now that it's been I've set up my new virtual environment, I need to activate it. So we'll do source, we'll do jokes, bin, activate. And what we can see now that I've activated, I know I'm in my virtual environment because right at my command line it shows me here in parentheses leading my prompt with jokes inside. Now I'm in my virtual environment, let's go ahead and install PyJokes. So pip install PyJokes, jokes. So this will connect out to PyPy, go ahead and download it and install it for me. And I've now installed PyJokes successfully. Now as we saw on up on PyPy, it provides me a command line utility, so I should be able to just type PyJokes and hit enter. Oh, sorry, look at that. It even tells me PyJoke is what I meant. PyJoke, and it gives me a nice little joke to go through here. So 3 database admins walk into a NoSQL bar. A little while later, they walk out because they couldn't find a table. Boop, a little bit of database humor for us today. Now let's see if we can get one more good joke out of the utility in our demo here. Oh, this is one of my favorites. I would tell you a joke about UDP, but you would never get it. Who doesn't like network humor about protocols? In summary, let's take a look at what we've talked about so far in this lesson. We've understood what Python libraries are. We now know how to use them, leveraging pip, and where we might get access to them. We also looked at the important virtual environment inside of Python and how we can use it to create isolated environments of different Python versions with different dependency libraries installed. And then lastly, we explored a few core libraries for displaying data, working with scripts, and running and managing the operating system that are there. All right, your call to action coming out of this one, make sure you complete the full Network Programmability Basics course. This is the second of 3 lessons on Python. If you haven't caught the first one, go back and watch it, and then also follow up with the next lesson in Python where we look at some handy Python libraries for network programmability and interacting with infrastructure and APIs. If you didn't run the exercises as we went through, go ahead and do those now so that you can become familiar with these capabilities. And of course, join me on DevNet up on developer.cisco.com, where you can get access to our learning labs and sandboxes to help you in your journey to network programmability. If you have any questions, feel free to come find me. I'm available on email or Spark at hapresto@cisco.com. I'm also up on Twitter and quite active at hfpreston. Cisco DevNet's also available on many of the social medias, available at Cisco DevNet on Twitter or Cisco DevNet on Facebook. And then we're all available up on GitHub, where we've got tons of code samples and ideas that you can use to get started. All right. Thank you so much for joining me for this lesson. I look forward to seeing you on the next one where we dive into more Python libraries specifically for interacting with network programmability topics. Thanks.